plumbing job. Which means that they're going to be able to figure out how to automate it much faster than an ordinary tech company full of humans would be able to figure out. Imagine you actually have this army of superintelligences, and they do their projections, and they're like, yes, we have the designs. Like, we think that we could do this in a year if you cut all the red tape for us.
Right. If you give us half of Manitoba.
Right. Yeah. And in AI 2027, what we depict happening is special economic zones with zero red tape. That the government basically intervenes to help this whole thing go faster. And the government is basically helping the tech company and the army of superintelligences to get the funding, the cash, the raw material.
Developing an AGI that could revolutionize its military. What do? Do you insist on slow, careful safety testing? Or do you, as Kakatayo suggests, greenlight a massive government-backed project in the Nevada desert with no questions asked? The pressure to unleash your nation's AI, to let it build, design, and deploy with no restrictions would be immense. The fear isn't just that the other side will get a better economy. The fear is that they will achieve a decisive, permanent military advantage. An intelligence that can design novel weapons, crack any encryption, and run trillions of wargame simulations per second could achieve a first-strike capability.
A neural network.
Is it really that simple? Can you show me an example?
Sure. Here it is. Every neural network starts with an input layer. In this example, it has one neuron that passes the reading from an analog input pin to 4 neurons in the first hidden layer. Input neurons simply hold and forward the input values through weighted connections. The hidden layer neurons then process this data the same way as described earlier, by applying an activation function. In this case, they're using the TNH function, which outputs values between -1 and 1. These then go to the output layer, which has 3 neurons using sigmoid activation, each one representing a single output. These control 3 EM or ESP32 platforms, but unfortunately, it doesn't run on tiny 8-bit MCUs like the Arduino Nano. But there is an alternative, AI-FES, developed by the Fraunhofer Institute in Germany. It supports pretty much any platform you can think of, from AVR-based Arduinos all the way up to PCs. AI-FES is great for super lightweight tasks like gesture recognition or pattern detection in sensor data. And it's easy to use. This is the same model as before, now translated into C for use with AI-FES. Honestly, it doesn't exactly look easy to use at first glance, does it? But fortunately, AI-FES provides an easy-to-use converter tool that generates this